I want to show the addition of 5/4 plus 2/5. In order to add fractions, we must first define our whole. We need to show both fractions in the same size whole so that way we can add them, we can combine them. We want to think about addition just with fractions just like we do addition with whole numbers. We literally want to just put these two pieces together and then find out how much we have in total, in sum. Starting with the set model, we need to define our whole so that way we can add our two fractions, 5/4 and 2/5. I will use these purple tiles to create my whole, create my set that will serve as my whole. So in order to show fourths, I need 4 pieces, and then in order to show fifths, I need 5 pieces. This is why I create in a 4 by 5 array, and I will fill in all of these pieces because you can see going down my columns vertically are my fourths. I have 1 column, 2 column, 3 column, 4 columns. Those are my fourths. My rows going across 1, 2, 3, 4, 5. Now from my whole I can create my two fractions. I want 5/4. So I will copy all 4 columns, that's 4/4, and create a 5th fourth by having another column. Now I want 2/5, so I will copy 2 of my rows to have 1, 2, 3, 4, 5/4 and 1, 2/5. So in order to add them together, I just combine both fractions. Adding is putting together or combining. Here's my 5/4. Here are my 2/5. And I will simply rearrange so that way I can see how much of the set I have. You can leave it like that, or you can start to see I have 1 whole and 13/20, or a total of 20 plus 13 would be 33/20. So now we can see 5/4 plus 2/5 is the same as 33/20. I did not have to find or any equivalent fractions to first convert and then add. By defining the fractions, by first defining the whole, being able to see both fractions, fifths as the rows and fourths as the columns, I was able to define my fractions based on that whole. Here is my virtual manipulative of the Cuisenaire rods, and I'm going to turn on the labels here so that way you can see how much each of these is worth. So in order to define this whole, I have to find one whole that can show both fourths and fifths. I can reason about these numbers thinking about an array of a 4 by 5 array that would show both fourths and fifths, and use that to apply to the Cuisenaire rods. If I had 4 yellow rods that are each length 5, I could also do 5 purple rods that are each length 4. This again connects and relates back to our set model. When we create a whole that shows both fourths and fifths, we create a 4 by 5 array, and it could be a 5 by 4 array representing the commutative property. Here we can see that as well. 4 groups of 5 or 5 purples 5 groups of 4. Thus, I know my whole is going to be defined as 2 tens, or a whole of 20 of the unit cubes. So I know that my purple rod is a fifth, excuse me. My yellow rod is a fourth. It's the opposite of the label, and that's where maybe turning the labels off could help us. 1/5, because there's 5 purples that make up the whole, 1/4. And now I want to show 5/4 plus 2/5. 1, 2, 3, 4, 5 plus 2/5. If this was long enough, I'd keep going, but I'm going to start down here. And maybe actually I'll move this one down here. Now we see, I'm going to turn the numbers back on. We have 1 whole plus 5 plus 4 plus 4. 8 plus 5, 13. Right? We're comparing lengths, so we have 1 whole and 13 twentieths. We didn't have to do any multiplication. We didn't have to find equivalent fractions to start. We didn't have to even talk about these as a common denominator before we added them. We used the models to help us figure out how much we had at the end. Once we defined our whole, then we could use the notion of 1, 2, 3, 4, 5/4 plus 2/5. I'm going to move these out of the way. And then once we figured out our sum here, put these all together. Once we figured out this sum here, now we know that that is 1 whole and 13 twentieths. So now let's take a look at the pattern blocks and see how we can represent 5/4 plus 2/5 using these same ideas from the set model and the linear model. We know that we need to define or create our whole that can show both fourths and fifths. So using the reasoning that we thought about with the set model, the 4x5 array having a total of 20 pieces, or even the lengths 4 rods that were length 5 or 5 rods that were length 4, again for a total length of 20, we can think about how can we create a whole with 20 pieces. So I know that the hexagon is made up of 6 green triangles, so there's 6. Here's another 6, so that's a total of 12. Here's another 6, that's a total of 18. And now I want 20. So I know that the blue would be 20. So I can define my whole as 3 hexagons and 1 rhombus. But now I think, okay, well, what would 1/4 of that whole look like? What would 1/5 of that whole look like? How can I show that in the shapes? Again, connect back to the Cuisenaire rods. I wanted 4 pieces that were length 5. So what would be 5 pieces in this instance? We could have a trapezoid and a rhombus. That would be 5 pieces, so this would be 1/4 of my whole. Length 4, or total of 4 pieces, this could be 1/5, or 2 rhombuses could be 1/5. Now that may be hard to visualize, so I wanted to draw out how we can see that. We can see that would be 2 rhombuses, that would be 1. Another 2 rhombuses could be there. Again, we don't need the same exact shape, we need the same area. Another 2 rhombuses would be there. Another 2 rhombuses would be there. And then this last 2 rhombuses would be there, for a total of 1, 2, 3, 4, 5 pieces in our whole. I encourage you to actually build that and see, but I wanted to show you how our 2 rhombuses could be 1/5. You can do the same thing with 1/4. So now in order to do our addition, we showed 1/4 and 1/5, but we don't want 1/4 and 1/5. That's on our addition. We want 5/4. So I'm going to create this shape, 1/4. We'll clone that. 2/4, clone that. 3/4, 4/4, and 5/4. And now I'm going to rearrange this so that way it looks like our whole. Not very accurate because I'm going to hand draw this, but we can see this shape as the trapezoid, and then which is half of that, half of the hexagon, and then a third of the hexagon is the rhombus. That's 1, 2, a trapezoid and a rhombus. Here would be another, so this is 1, 2, another trapezoid, and then again we can picture, and maybe picturing it is tough, we can actually put it on top. Trapezoid and a rhombus. Do this trapezoid, trapezoid, and a rhombus. So we can see, and then what we have left is a trapezoid, and then now these 2 little triangles, which is the same area as this rhombus. So we see this shape is 1/4. Here's the second fourth. Oops, sorry. We can see this one right here as our third fourth. And then now we have this space left over here. Maybe I'll change my color to green. I'm going to circle this in green, right? The areas we're looking at in pattern blocks. So we have the rhombus, or sorry, the trapezoid, the red trapezoid, and then the 2 little triangles, which is the same area. That's our 4/4. So that we could see the whole and how these 2 shapes make up the 4th and the 5th in this whole. Right, we want to think about this idea of common denominators. We know in the set model we can create an array, a 4x5 array, so then we'll have 20 counters. So we can use that same reasoning of, well, our common denominator is going to be 20, and if we want to define that as our green triangle is 1/20th, then we can see that we'll have 20 green triangles in this shape. I erased all of the markings here in my whole, and I'm going to delete these pieces. And then what I want, no, that one doesn't get deleted. What I want to show you is that we want to show both addends when in all of our models, any of our models. So we can take our 1/4 and make 5 of them to make 5/4. If you're still wondering how this is the same, I'm going to copy these and rearrange them so that way we can see. So I gotta ungroup. we can see this whole. So we know, again, two trapezoids are the same as a hexagon, take up the same space. I'm going to make this look like that one there. So here we are, hexagon here, hexagon here, hexagon here, hexagon here, and now we have our extra rhombus there. But remember, this is not a whole, this is 5/4. So what we see is we have a whole, let's see, with our 4 red trapezoids and then our 3 blue rhombi. Sorry, this won't. And then our extra 1/4 piece here. So here again, our 3 hexagons and our blue rhombi, 1, 2, 3 hexagons, blue rhombi, and then our extra 1/4 piece. So here's our 5/4. We can then scroll down so that way you can see our just a screen. Our 1/5 here, we just do 2 of them to make 2/5. So here we have 5/4, and now we'll take our 2/5 and we'll put them all together. And now we can figure out our sum. So we see we have 1 whole, and some more. What is this extra? We can think about it in terms of 20ths by counting each of these green pieces that take up the same space. 2, 4, 6, 8, 10 plus 3, 13 20ths. Or we can think about it in terms of 4ths and 5ths, but as we just counted, 13 20ths is not going to be equivalent to either 4ths or 5ths. So adding the labels on here, again, I just put all of the pieces together. Here, this is the same as 33 20ths, right? We see our whole, we can replace some of the equivalent areas, right? The blue with the green. We see we have traded out 2 blues, 2 greens for 1 blue, 2 blues for 4 greens, and think about this as 5/4 plus 2/5 is the same as 33 20ths, or 1 and 13 20ths, as we saw here. All right, the 1 whole, and then we counted these 13 20ths.